Hi everyone, let's look at this question on the exponential equation. Now, so we have 2 raised to the power of 2x plus 2 minus 33 into 2 raised to the power x plus 8 is equal to 0. So at this point, we can split these to be 2 raised to the power of 2x by the law of indices. The addition, when the power is an addition, then it means that the base must be multiplication. So we have times 2 raised to the power of 2 minus 33 times 2 raised to the power of 8 x plus 8 is equals to 0. So at this point, we can see that 2x here are common. Let's say our 2 raised to the power of x is equals to p. Then we now have p raised to the power of 2 times 2 raised by 2 minus 33p plus 8 is equals to 0. So at this point, we can say 4p squared minus 33p plus 8 is equals to 0. So you can see that it transforms the quadratic equation. So at this point, you multiply the first term by the last term. That is the coefficient of p squared, which is 4, to the last or the constant term, which is 8. So 4 times 8 is 32. So here, we are going to look for two numbers such that when you multiply it, it will give you 32. When you add it, it will give you minus 33. And the two numbers are minus 32 and minus 1, because minus 32 as minus 1 is 32, and minus 32 plus minus 1 is minus 33. So at this point, we split the two terms in the middle of the quadratic equation. So we have 4p squared minus 32 times the p minus p plus 8 is equal to 0. So at this point, you factorize. So you factorize, what is common here? 4p is common. So you write 4p as the highest factor that can go into 4p squared minus 32p. So 4p in 4p squared, you are left with p minus 4p in 32p, you have 8. Then, what is common here? 1 can go in this. So I have minus 1 into p minus what? 8 equal to what? 0. So at this point, you write out the highest factor. That is the terms outside the bracket. So which is 4p minus 1 into the binomials that are common, which is p minus 8 all equal to 0. Therefore, 4p minus 1 is equal to 0, or p minus 8 is equal to 0. So collecting like terms, 4p is equal to 1. Therefore, p, our p will now be 1 over what? 4. Or our p is equal to what? 8. So if p is equal to 8, p can also be 1 over 4. But from the beginning of our solution, we say let 2 raised to the power of x be equal to p. So we are going to replace p with 2x. So we now have 2x is equals to, let's start with this, p is equals to 8. Therefore, to get, we now have 2x. Now to get our x, we have 2x is equals to, in index form, x can be written as 2 raised to the power of 3. Therefore, if we equate them, 2, the base will cancel. So we have x is equal to 3. Now, when p is equal to 1 over 4, so we now have 2 raised by x is equal to 1 over 4, which means that 2x is equal to, I can write this in index form as 2 raised to the power of minus 2, because 1 over 4 can be written as 1 over 2 raised to the power of 2. So 1 over 2 raised by 2 can be written as what? 2 raised to the power minus 1, using or applying the law of indices. So at this point, you can see the base are common. So this will cancel this. Therefore, x is equal to minus 2. Therefore, finally, our x is equal to 3 or minus what? 2 as our final answer. If you find this video helpful, please follow or subscribe to my channel by clicking the button below to see more of my videos. Thank you.